Purpose of this video is to help you convert between mass and moles, two important quantities or ways of describing um, chemical quantities. Okay, so first off, when you are looking at what a mole is it's a quantity. It's like dozen, where dozen refers to that you've got 12 things. So moles is a similar kind of thing, except it means if you have one mole, it means you have 6.022 times 10 to the 23rd things, not just 12. And when we're dealing with chemical reactions, we typically aren't dealing with, just a few molecules like that. We are dealing with lots more molecules, so astronomical numbers. But we need to convert back and forth between those. One of the main reasons why we need to do that is when we look at chemical reactions, all chemical reactions, let me just balance this one, all chemical reactions are written in terms of moles. So I have 1 mole of this reacts with 5 moles of that. And if I do that, it's going to give me 3 moles of this and 4 moles of that. This does not mean I have 1 gram of this reacts with 5 grams of that, because these things would weigh differently. So in a chemical reaction, they're written by moles, and so I can't use grams for that. So when I'm doing stoichiometry, things have to be in moles. But the problem is that the scales that we have just measure in grams. It'd be nice to have a scale that would measure in moles, but then I guess you'd have to say what you're putting in there. And at any rate, our scales measure in grams, not moles, so we're going to always have to be converting between grams and moles. And that's the purpose of this video, is to help you go back and forth between them. One thing that is handy and that, required in order to do this is some kind of a conversion table that helps us convert from a mass in grams to a quantity in moles. This conversion unit depends on what stuff you have. Like you've heard the thing, a pound of feathers, a pound of gold. It's different stuff. They both weigh the same, but you'd have a ton more volume of feathers than you would gold. So we have to have some kind of conversion factor. And that conversion factor is found on our periodic table. If you take a look, and this one I've got zoomed into iron, this number right here is my conversion factor that I need for iron. And 55.85 is the number of grams that 1 mole of iron would weigh. So if I have a mole of iron atoms, they would weigh 55.85 grams. And notice that each element on here has a specific number. So these are our conversion units that we can use. To do any kind of conversion, you can use one of 2 different methods. And I like both of them, and I guess you need to pick one and probably stick with that. In most of my classes, we use a formula-driven way, but I quite like this other way too. It's known as a dimensional analysis, and what you do is you write down what you're given, multiply it by some kind of conversion unit, and that gives you your answer. Let me give you an example of one. So if they say how many moles are in 25 grams of calcium, okay, well I write 25.0 grams of calcium, multiply it, I have to multiply it by a conversion unit. Here's my conversion unit right there, 40.08. But 40.08 is really 40.08 grams in 1 mole of calcium. So if I'm wanting to convert this, I want to get rid of the grams and keep moles. So I've got to put what I want to get rid of on the bottom. 40.08 grams would be on the bottom, is the same as 1 mole of iron. Here the grams would cancel, and now I simply would go 25 times 1. Let me do that on my calculator. Divided by 40.08. So this would be 0.624 rounded to 3 sig figs like I have in the question there, moles. 25 grams weight on the scale is the same as 0.624 moles of calcium. So that's dimensional analysis. Here's another way you can do it, and it's a formula. N stands for moles, little m stands for mass, and big M stands for molar mass, or atomic mass. So for example, in this one, if they want to know how many moles in 56 grams, I'm looking for moles, so I put an N there. Mass, that's this one in grams, 56.0 grams, divided by the molar mass of aluminum is right here, 26.98. 26.98 grams per 1 mole. Notice when I said per, instead of putting a per down here, I just put it across that fraction line. That's good practice to do. Grams cancel out. All I have to do is go 56 divided by 26.98. It gives me let's round this to 3 sig figs, 2.08. 2.08 moles. So if I weigh some aluminum and I have 56 grams of it, that's the same as 2.08 moles of aluminum. Okay, so that'll help you convert between grams and it'll convert from grams to moles. How about going the other way? So if I have a certain number of moles of aluminum, I want to know how many grams that is. Two ways you could do that. I like using the dimensional analysis. 5.63 moles times, no, aluminum, I just did that one, 26.98. And the 26.98 is grams for every 1 mole. So if I want to get rid of moles, I'm going to put that 1 mole on the bottom, and I'll put my grams up top, 26.98 grams. If I multiply that, 5.63 times 26.98, 151. 151, well, let's see, 3 sig figs, let's call that 152. 152 grams. So if I have 152 grams of aluminum, that's the same as 5.63 moles of aluminum. Let me show you how you could do this with that formula though too. If I have moles is equal to mass over molar mass, that's my formula. This time I'm looking for grams, so I'm wanting to find out what that is. If I want that by itself, I have to get rid of this molar mass, just manipulating the equation. So I'll multiply this side by a molar mass. If I do it there, I got to do it on this side. Here they cancel. This is sort of math, manipulating stuff. So my formula becomes molar mass times moles is equal to mass. Molar mass is 26.98 grams per mole times the moles that I have, 5.63. 5.63 moles. So they cancel. If I multiply those two things, I'm going to get the same as I did up there. So that's two ways that you can change from grams to moles or moles to grams. I would suggest picking one way and doing it that way all the time. Now the last thing we can do is that when we're doing chemical reactions, we're not always just looking at one atom. Often we're looking at a compound. And so while this one here, strictly I would call that the atomic mass. If I'm looking at a compound, I'm looking at something else called a molar mass. But really they're the same thing. How many grams would 1 mole of something weigh? When you're trying to figure out the molar mass, what you need to do is just add up how much stuff is in that particular compound. When you're looking at a balanced chemical equation, you don't use the coefficients, don't use those, you just use the little subscripts. So for example, if I wanted to figure out the molar mass of sucrose, so sucrose is C12H22O11. Why did I pick that one? Anyway, that's a big one. So it means I have 12 atoms of carbon, 22 atoms of hydrogen, 11 atoms of oxygen in 1 molecule of sucrose. And I want to figure out the molar mass of that. So what I do is I just separate them out into each element. So I've got a carbon, I got a hydrogen, and an oxygen. How many atoms of carbon? There's 12. Hydrogen, there's 22. Oxygen, there's 11. So what is the atomic mass of carbon? You look up on your periodic table, it's 12.01. Hydrogen, it's 1.01. And oxygen, it's 16.00. Those are the numbers right off the periodic table. Now what you do is you just times those. So 12 times 12.01 gives me 144.12. Hydrogen, 22 times 1.01 gives me 22.22, I think. And then 11 times 16 is 176. So that is the sort of subtotals for each element. Then to figure out the total molar mass of sucrose, you would just add those up. So that plus 1, yeah, plus equals 342.34. That's how many grams there would be in 1 mole of sucrose. So this number here is your molar mass of sucrose. Hopefully that helps you. Make sure that you are good at converting between grams and moles.